Hi friends, today we're going to talk about a fascinating phenomenon known as static electricity. Static electricity is a type of electrical charge that builds up on the surface of materials, usually due to friction. It is called static because the charge tends to remain in one place, rather than flowing like the electrical current we use to power our devices. You can easily observe static electricity when you rub certain materials together and notice sparks, or when your hair stands up after you walk across a carpet. This effect is a result of an imbalance in the electrical charges on the materials involved. Now, let's explore what exactly happens when different objects rub together to create static electricity. What happens when different objects rub together? When two different materials rub against each other, the atoms in these materials interact in a way that causes electrons to be transferred from one material to another. Electrons are negatively charged particles found in atoms, and they are the ones that move when electrical charges are created. The object that loses electrons becomes positively charged, while the object that gains electrons becomes negatively charged. This transfer of electrons is the essence of static electricity. For example, imagine you rub a balloon against your hair. The rubbing action causes some of the electrons from your hair to transfer to the balloon. As a result, your hair becomes positively charged, and the balloon becomes negatively charged. These opposite charges lead to an attraction between the balloon and your hair, or even the balloon sticking to a wall. The order of charge transfer in materials like wool and silk. Let's take the example of wool and silk. When wool and silk are rubbed together, the wool tends to lose electrons and becomes positively charged, while the silk gains electrons and becomes negatively charged. This happens because of the different tendencies of the materials to hold onto their electrons. Wool has a greater tendency to give up electrons, while silk tends to hold onto them more strongly. This phenomenon is explained by a concept called the triboelectric series. The triboelectric series is a list of materials ranked according to their tendency to either lose or gain electrons when rubbed against other materials. Materials at the top of the series, like silk, tend to hold onto electrons more tightly and thus become negatively charged, while materials at the bottom, like wool, are more likely to lose electrons and become positively charged. When you rub wool and silk together, the electrons from the wool move to the silk, creating an imbalance of charges. As a result, the wool becomes positively charged, and the silk becomes negatively charged. This creates a static charge that can produce sparks or cause the materials to attract or repel each other. Why does this happen? This transfer of electrons occurs because of the differences in the way atoms interact with their electrons. The outermost electrons in atoms are the easiest to remove or transfer. Some materials, like wool, have atoms that hold onto their electrons less tightly, while others, like silk, have atoms that attract electrons more strongly. This difference in attraction causes the electrons to move from one material to the other when they come into contact. Examples of static electricity in everyday life. Static electricity is everywhere around us, and we encounter it in many different ways. Here are a few examples. Rubbing a balloon on your hair. As we discussed earlier, rubbing a balloon on your hair causes a transfer of electrons, leading to a static charge. The balloon can then stick to a wall or attract small pieces of paper due to the opposite charges. Shuffling your feet on a carpet. When you walk on a carpet, especially in dry conditions, electrons are transferred between your shoes and the carpet. This can result in a buildup of static electricity. When you touch a metal object, you may feel a small shock as the excess charge discharges. Clothes sticking together. If you remove clothes from the dryer and they stick together, it's likely because of static electricity. The friction in the dryer causes electrons to transfer between clothes, leading to a static charge. This is why synthetic fabrics, like polyester, are more likely to cause static cling than natural fabrics, like cotton. Lightning. One of the most dramatic examples of static electricity is lightning. When clouds rub together in a storm, they can build up a massive static charge. This charge is eventually released in the form of a lightning strike, which can discharge the excess static electricity. The role of humidity in static electricity. Static electricity is more noticeable in dry conditions. This is because moisture in the air can help dissipate the buildup of charge. In humid environments, water molecules in the air attract electrons, making it harder for materials to hold onto their charges. This is why static electricity is more common in winter or in dry climates, where the air is less humid. Safety and uses of static electricity. While static electricity can be fun to experiment with, it's important to be aware of its potential risks. For instance, static electricity can cause sparks that could ignite flammable materials. This is why it's crucial to discharge any built-up static before handling sensitive equipment like computers or electronics. In fact, many electronic devices are designed with anti-static protection to prevent damage from static charges. On the other hand, static electricity also has many useful applications. It is used in devices like air purifiers, which attract dust particles through electrostatic charges. It's also used in photocopiers, where static electricity is used to attract toner onto paper to create an image. Conclusion. In summary, static electricity is a fascinating phenomenon that occurs when electrons are transferred between materials through friction. This transfer creates an imbalance of charges, resulting in materials becoming positively or negatively charged. The effect is often seen in everyday life, such as when we rub a balloon on our hair or experience static cling in our clothes. The order of charge transfer depends on the materials involved and their tendency to gain or lose electrons, as shown in the triboelectric series. Static electricity is an interesting and important concept with practical applications, but it's also something to handle carefully in certain environments. Thank you for watching, and I hope this explanation helps you understand static electricity better.